parallel lines, do they ever intersect? No. Why don't they intersect? What do they have on common? Or have in common, excuse me. Well, aren't all lines the same length? They're all infinite?
Well, yeah.
There it is. Slope. Okay? The same slope. Remember, parallel lines would have what's called the same slope. Now, we'll get into slope stuff here probably towards the end of next week a little bit. We kind of revisit writing equations of lines, writing equations of lines that are parallel, writing equations of lines that are perpendicular. We go back to all of that, but the main idea here is that when you have what are called parallel lines, we say that they have the same slope. And then you see this symbol. The symbol on those are little arrows. They're usually just a directional arrow, and that just means that those two lines themselves are parallel. Okay? We use the abbreviation, I'm sure you've seen this. You guys have all seen the double slash line? That stands for parallel? I'm assuming you've all seen that? And then this would be, what would that one be? Yeah, perpendicular. We like to use symbols for it because parallel and perpendicular is just too many letters. Okay? Too many letters. Now, one of the things that we also want to define is something called a transversal.
Trans, from the Latin, meaning across, and versal, meaning cut. Literally, the word means cutting across. Isn't that cool?
I wish we didn't know all the Latin stuff.
E pluralis unum, or whatever it is.
So trans, across. Think about like the transcontinental railroad, right? Across, right?
Yeah, I'm just trying to remember the only Latin I remember, and it sounds like the dollar bill. So the idea here is this thing, like Mr. Snow was talking about, what's transversal. A transversal in our case, like she was saying, it cuts through. Think of it as a line that cuts through. Oops. Two or more lines. Transversal is just a line that cuts through two or more lines. Okay? And what happens here is something pretty easy. These guys are all lines. There'll be little arrows on the end showing that they're directional. I've got my what are called parallel lines, and then I have my transversal. Okay? When you have the transversal go through, you'll notice how many total, we have two parallel lines and one transversal. How many angles are created if you count all those up? 8, okay? Remember we talked about this before. When you have two lines that intersect, you get how many angles? We got 4 of them, right? So if you look at this, we have 1, 2, 3, and 4. And I'm just going to look at those two first, or that setup first. We know for certain something about some angle pair relationships. What do we know about 1 and 3? Why? What are they called? No. The bow tie thing, they're vertical. I thought you said it. Sorry, the voices came from this way. You're looking right at each other. Vertical. Angles 1 and 2 are the same because they are vertical. What about angles 4 and 2? I'm sorry, 1 and 3, excuse me. 1 and 3 are the same because they're vertical. What about 2 and 4? Same thing, isn't it? Now, we know those two would be the same, and those two would be the same. You okay with that? Now, we also know that angles 1 and 2 add up to equal how much? 180 because they're a linear pair. They're supplementary, they're next to each other. We know that angles 2 and 3 form a linear pair. They're adjacent supplementary angles. 3 and 4, 4 and 1. Those are all things that we discussed last week when we had the two lines intersecting. What changes today is that this transversal thingy basically transfers all of those same angle measurements to the other line. All of these angles here, and I'll label them, we started 1, 2, 3, 4, so we'll be at 5, 6, 7, and 8. Those angles, those 4 angles, and those 4 angles above will all share the same tick marks. So angle 1 has 2 tick marks, which means angle 5 would have 2 tick marks. Angle 2 has a tick mark, so would angle 6. And so on and so on. And those two have to be the same. Oops, sorry, too many ticks. It doesn't matter. If one got 1 tick mark, 2 would get 2 tick marks. As long as you're keeping it consistent, it's fine. Okay? The same idea that I can do that if angle 1 has a happy face, angle 3 has a happy face. If angle 3 has a happy face, angle 5 has a happy face. If angle 5 has a happy face, angle 7 has a happy face. So then star, 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 star. As long as you're consistent, it's just a lot easier to draw tick marks than it is multiple smiley faces and multiple stars. Okay? Does that make sense? Now, the reason why all of this works is because there's some vocab going into play here. And this goes into the idea of what we call 4 types of angles created with 2 parallel lines cut by transversal. And what we're going to look at today are the 4 types and how we set it up to do some algebra. Right. Excuse me. So what we do here is we write that out a lot. 2 parallel lines cut by a transversal. And us being math people, not liking to write things, we like to come up with symbols. Hence why we have symbol for parallel, symbol for perpendicular. We have symbols for everything. We have a symbol that shortens up the writing of 2 parallel lines cut by a transversal also. And it looks like this. Whenever you see that, this stands for 2 parallel lines cut by a transversal. Okay? This means that's what that means. It's just short. You guys know what I mean by shorthand, right? It's just an easier way to write it. It means the same thing. It's just symbolically meaning it as opposed to writing it out in words. So we have 4. We have corresponding, alternate, interior. And I'll draw pictures of all of these here. Corresponding angles, those are just angles that are in the same position. Angles are in the same spot on the same side of the transversal. For example, that angle is in the top left. The corresponding angle to that on the other one would be also the top left. Think of them as in angles in same position. Okay? Those angles will always be congruent. When 2 parallel lines are cut by a transversal, these guys are, remember, congruent means same measure. Okay. So when you have corresponding, If I'm looking at this picture here, what corresponds to angle 2? What corresponds to 7? What corresponds to 4? What corresponds to 5? See how that works? Pretty easy, isn't it? And those measurements will always be the same. If angle 1 is 100 degrees, that means angle 5 is 100 degrees. Which then also means that angle 7 is 100 degrees, which also means that angle 3 is 100 degrees. And that's how this stuff is going to move. Alternate interior. Now, alternate interior will be angles that are inside the line on opposite sides. Inside, opposite side. 4, 6. Inside the lines, opposite side. 5, 3. Inside, opposite. So inside, opposite. Sides. These guys are also congruent. One of the things that'll happen here, guys, is that when we do get the parallel lines with the transversal, at most, you're only going to have 2 angle measurements. The only time you'll have 1 angle measured if they're perpendicular to each other, because then all will be 90 degrees.
Because your parallel lines on your shirt.
It's pretty sweet, isn't it?
It's sweet.
Perfect.
It's very sweet.
Both people?
But it just ties in nicely.
Greatest football player of all time?
I know that.
It was awesome. Here, sure. So good? So what's alternate of 6 again? We're looking at the generic diagram? 6 and 4. Okay. Now with corresponding alternate interior, the other 2 are alternate exterior. And then this textbook does same.
It's gonna say same side.
I think they say same side interior. I'm gonna use the. I know. I'm gonna use the book. Same.
Do you say X?
What's that?
There's an
Do you say
extra.
X?
Oh yeah, I might have done it and just didn't. There. Yeah, the last one's gonna be called same side interior, and I'll show you guys here again what those are gonna look like. Alternate exterior. Well, if alternate interior were on opposite sides on the inside, what do you think alternate exterior gonna be? Opposite sides on the outsides. There you go. Alternate exterior are opposite sides on outside. Let's go look at the picture. Here's my parallel lines. If I have my generic diagram here, if I pick this angle here on the top left, it would have to be the bottom right. Opposite sides on either side on the outside. Okay? So here, I'm looking at angle 1. Angle 1's top left. Angle 7 would be the bottom right. Opposite sides on the outside. 1 and 7, 2 and 8. Those guys are also congruent. These guys are also congruent. If this angle here is 60 degrees, that means this angle here is 60 degrees, and so on and so on. Which means that this one would be vertical, this one would be alternate interior, and that's vertical. And they jump back and forth. They're really, 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 really fast. Okay. And then the last one is called the same side interior. Gee, I wonder where those are going to be at. We can only figure out by the term same side interior where those would be. I don't know. I'm going to guess they're on the same side on the inside. Now these are a little bit different in terms of what they wind up equaling. If I go to my diagram we had off over here with numbers, the ones that are on the same side of the inside, remember we're talking about inside the lines. 4 and 5 are on the same side on the inside. You okay with that? 3 and 6 are on the same side on the inside. Now, if I look at our diagram here, when I put in those 60s, these two angles aren't going to be the same value, will they? No, they're not. So watch what happens here. If we know that 60 degrees is on one side of an angle, what's supplement to 60? 120, good. So if this is 120, that means, what does this have to be? Which means, what does this have to be? Which means, what does this have to be? What's the relationship between those two? Which means they are excellent. Same side inside are always supplementary. Same side inside are always supplementary. And remember, when you're supplementary, that means you add up to equal 180. Because what comes first in the alphabet? Complementary or supplementary? What comes first as you're counting? 90 or 180? 90. So 90 complementary, supplementary, and 180. Okay. That's what this stuff looks like, guys. It's the idea of, can you identify which scenario are you looking at? Okay. The main thing that I would always say to do when we have what we call parallel lines cut by a transversal is as soon as you see a problem that has parallel lines, and you see the little arrow thingy here, and you've got a transversal, what I would always do is I start and I mark my diagram. That's congruent to this. Alternate interior means this is congruent to this. If the diagram, if any angle shares a tick mark, they're always equal. If the diagram does not share a tick mark, if it has the same number of tick marks, they're equal. If they have one of each, they're always supplementary. Because it has to be. No other way around it. This means they're parallel. That just means that they're parallel. It's another way of showing that we have parallel lines. It's different than when you did in algebra. Look at a diagram. Yeah, give it another minute or two and be like, oh. Trust me. Maybe. All right. Show you an example of that. Actually, I think I have this copy. I brought up. Yeah, I did make this one for you guys. I forgot. Oh, I forgot the whole bunch of it. Oh, that's it. Try not to pay attention. I forgot the hole punches. I apologize. I got a hole punch back. Now, what I'm doing here is I want you guys to get in the habit of drawing the tick marks as we go through the diagram. Because tick marks allow us to see whether or not things are equal or not equal. Don't worry about that little weird epsilon looking thing with the 1. It means angle. Okay. So if I'm looking at 5, automatically what I do for any diagram like this, I always start in my upper left-hand corner and I put a tick mark. I know then to automatically go vertical because vertical angles are always congruent. As soon as I do that, I'm now on the inside of my parallel lines. When you're on the inside of your parallel lines, you're going to look at your alternate interior. So I go opposite side on the inside. So I switch across and I put another tick mark. And then the last vertical. That means every one of those singular tick marks has to measure how much? 60. Okay, see how that works? Every one of these angles has to be 60 degrees no matter what. Which means every angle that doesn't have that tick mark has to measure how much? Excellent. Because it's always going to be the supplement. Always. It never changes. As soon as these guys are parallel, this happens automatically. Okay? It happens automatically. All right? Sorry? Be better than that. No, it was something concept. Look at 7. Same idea. Over at 7, I'm at the top left. Again, I put a tick mark. Vertical, alternate interior, vertical. That means all of those angles are going to measure the same amount. Do I know what that angle measure is according to the diagram? But can I figure it out?
Yeah.
What is it going to be? How much? 100. It's going to be 100. And because this is 80 next to it, that means that the angle sitting next to it has to be its supplement. Supplementary angles always add to 180. So if one of them is 80, the other one has to be 100. So everywhere I see that tick mark, what do I have to put then? 100. Everywhere there is not a tick mark has to be then how much?
Why is the 2 there?
It just says find the measured angle 1 and angle 2. That's all it means. Okay. I'm just using the diagrams right now to show you guys how this works. Okay. All right. Let's look at number 8. That's what, a 56? Okay. Same thing, guys. Same exact same thing. I put a tick mark here. Vertical. Alternate interior. Vertical. Every one of those angles that has a tick mark now has to measure how much? 56. Because it says so. Because those guys are all congruent. And then how would you find the other angles? Subtract 56 from 180, and I think you get, was it 124? Does that sound about right? Yeah. So every other one of those angles would be 124, and so on and so on. Okay? Not too terrible, is it? Now, let me ask you another question then. Remember, we had 4 angle types. We had corresponding, same position, same side. Same position, same side. We had alternate interior, inside, opposite side, alternate exterior, outside, opposite side, and then same side interior, same side inside. What's the relationship between the angle of 117 degrees and angle 1 in number 9? Which of the 4 is that? Which of the 4 is that? Corresponding, very good. They're in the same spot. And we know then that corresponding has to be congruent. They have to be equal. Okay. They have to be. Again, we just follow our tick marks. Every one of those that has a tick mark would have to equal the one, what is it, 117. Okay. Now, I want to show you what happens when the diagrams move a little bit. Take a look at number 11 on your sheet. Oh, I got to run here. Let me check here one second. Take a look at the 11. The diagram isn't straight across like we've been working with, is it? Could you tilt your paper? Now does it look straight across to what you were doing? That's all you gotta do. What I mean here is to make it easier as far as perspective is considered, just tilt your page.
Yeah, you know, I'm like,
That's all right, that's all right. So what I would do here again, same idea. Tick mark, tick mark, tick mark, tick mark. Every one of those angles has to be the same. Did I happen to run into the 110 that was given to me for any of those? Sure. No. But do I have enough information to figure out what the missing angle is? What does it have to be? 70, good. So the tick marked angles are all going to be 70 because they are the supplement, because they're next to it. The non-tick marked angles in this case all have to equal what? Perfect. Two angles that are next to each other that create a line are always supplementary. Supplementary angles have to equal 180. Okay? And that's where we're going. It'll take a minute or two, you'll be alright. So that gets you your 110 everywhere else. Just a little bit. We'll get there. It's alright, it's alright. Now, number 12. On 12, what's that little square box mean again? 90. So if that little square box is 90, what do you know about all four of the angles around that 90 have to be? 90. What about all the angles above it? 90. As soon as you get one right angle, when you have the two parallel lines cut by a transversal, you know that all of them have to equal 90. Remember, the rule is, supplementary, 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 that goes all the way around. And then if you just follow the idea that alternate interiors, they also get the right angle, which means all of these have to be right angles. That is an example of your notebook. You've got blue lines on your paper. You've got that red tab line coming down. If you look at just the regular, your lined paper, that's what that looks like. That's why that works. Okay? Waiting.
I'm good. I'm just trying to think.
It's okay. Don't worry. I'll get you guys caught up. You guys missed out on this stuff. Caught up. It won't take long. We'll be doing this for a few days. When I look at 13, what are you going to do your paper on 13 to make it easier on yourself? Tilt it. Okay. So if I spin this around a little bit, make it easier on me. I'm going to do this. All right. Now, when I look at it like this, I'm going to do my tick marks like I have been. Start in the upper left, work my way through. That means that every one of those angles that has the tick mark has to be the same value. I did not run into anything that I was given as far as the information was concerned. The angle that I was given here was 95 degrees. Which means, what do I do to figure out the other angles? Subtract from 180. Because these two angles are supplementary. These two angles are supplementary. These two angles are supplementary. When you have two lines that intersect, two angles will always be like a linear pair, which means that they're always going to be supplementary. And you're right, 85s all the way around. So that means that y is 85, but what does x have to be then? 95. Very good. Yes, sir. Because these guys, when they are opposite side on the inside between the lines here, they're called alternate interior. If the lines are parallel, that's what these symbols stand for. These two guys will always be congruent. These two guys will always be congruent. Okay? And that's where the stuff comes from.
I got you.
All right, let's flip it over and let's look at algebra, because why not? Huh? Should be. The idea for the algebra here is follow your tick marks. If you can mark a diagram, you can do this stuff all day long. So on 17, what am I going to do first? Exactly. I'm going to tilt my page. All right, I'm going to rotate my page to make it easier on me to figure out what in the world's going on. Okay, now that I've done that, I'm going to start marking my tick marks. I go top left, vertical, then we do what's called the alternate interior and vertical. So as you mark this up, did those two angles share, or do those two angles share a tick mark? Therefore, what do they have to be? 80. They have to be equal. Well, algebraically then, I know that the x plus 15 angle has to equal 80. That's what this is doing.
Gosh.
What do you do? And what do you get? Excellent. Mess with perspective on your sheet. Rotate it around. Make it easier on yourself. That's the big trick. Yes, sir. Yep. Again, for those of you guys who are out there doing this stuff, we have 4 types of angles. Oops. We had the 4 types of angles. We had when you have 2 parallel lines cut by a transversal, you have the first one was called corresponding. Corresponding are ones that are in the same spot on the same side of that transversal. Transversal is just a line going through 2 lines. That's all that means. Okay. So the numerical one that I put over here, I said that 1 and 5 were corresponding. 4 and 8 are corresponding. They're in bottom left, bottom left, bottom right, bottom right. That's how those work. Those guys will always be equal. So if this is 100 degrees, this is 100 degrees. It also works vertical. We know that one. Alternate interior, bless you. Alternate interior were those 2. Those 2 angles were the ones that are on the opposite sides on the inside. These 2 guys will always be the same if the lines are parallel, as well as the other 2 going the other way. So in my numerical example, 3 and 5, 4 and 6. Okay. The third one was what we called alternate exterior. Those were opposite sides on the outside. Again, they're going to be the same angle. And then the last one was the same side inside. Same side inside aren't necessarily going to be the same, but they will always be supplementary. So as we go through these things, what we're doing is we're just identifying which ones match. And in this example, what we were just marking off, tick mark, tick mark, tick mark, tick mark. If they share a tick mark, they're equal. Or if they don't share a tick mark, they're equal. If they have one and one doesn't, they're always supplementary. Always, if the lines are parallel. And this is how where all of this little math stuff comes from. So let's try another one here. Look at what's this? 18. 18, the very next one. When you rotate your paper, And I would just sit there and start marking up, well, which ones are going to be the same. That way I know when I go back to looking at it, how to set it up. See what I'm doing there? All I'm doing is marking everything up. So I know if they're going to be equal or they're going to be supplementary. What's that? Super easy. You'll be all right.
Yeah,
You'll be all right. I, however you want to say it. Yeah. Shouldn't be so bad. No, you all the rest of it out there. They're all kind of the same size. They're all the same bit. Just a quick little soft. Mark them and go from there, okay?